Okay, this will be a quick overview of how to use PyPlot in the Julia programming language. Under the hood, PyPlot calls the data visualization library matplotlib, which is written for Python. Anytime I want to make a plot, I will go to the matplotlib gallery, browse through the plots that it's capable of producing, and click on an example where I want to mimic it. And it will show you the code used to generate that plot as an example. So there are lots of examples. And whenever you convert this into Julia, it's virtually the same syntax, except whenever you see these ticks, you need to use double quotes to make a string in Julia. Another difference is, for example, if you see capital T true as a Boolean in Python, you need to use lowercase because that's how you write a Boolean in Julia. But the syntax is largely the same. I posted a link to documentation for Matplotlib as well. Often you can just Google what you want to do with Matplotlib and something will come up. So let's start by making a bar plot to visualize how Americans like their steak done. And I included a data set here, a CSV file, in the data folder. So we can look in Vim, we can look in data/steak, and this is our data. So the first column, each row is a person. The first column is the answer by that person to the question, do you like steak? The second column is, well, if you do like steak, then how do you like it done? So we have medium rare, rare, medium, medium well. If a person answers no, they don't like steak, then we don't go on to ask them this question, how do you like it cooked? Because it's irrelevant. So let's read this in so we can visualize the steak preference of people. So we'll use a CSV package, dfsteak equals csv.read. And then we need to find out where our file is. And let's look at our present working directory, right? So here I am in this directory, and it's in the data subdirectory. So I'll use this join path command, okay? So join path data steak.csv, and this will stitch them together and make this string for you. Okay, so I'll read in this file, and voila, here is our data table. You can see that erroneously, the first row was read in as the header. However, in this, this of course is not the header. A header is missing from this CSV file. But we can pass a header to the csv.read function, and it will assign these column names. So we'll make the first be eats steak, because it says whether or not someone eats steak. The second, how cooked, how they like the steak cooked. And now you can see that no longer the first row is being read in as the header, and we have these headers. So these question marks are here because it's warning us there are missing values in these columns. All right, so let's drop the rows with missing values because we're only interested in making a plot conditioned upon people who like steak. So we can do that with the drop missing function. The exclamation mark tells us we're going to actually modify this data frame by dropping rows. You can see that this doesn't work because the data frame, the columns are not mutable. So we need to pass in copy calls equals true to make sure that the columns are mutable. Now it allowed us to drop the rows, add missing values, and that we no longer see the question mark here. Just to be sure, we'll make sure that all of the answers in this column are yes, so that the data pertains only to people who actually eat steak. So let's look at all the rows and eat steak, that column. So a bunch of strings, it's an array of strings. And we'll look at the unique values in that array of strings. And yes is the only value there, so that's good. All right, so now let's count the folks who like their steak done rare, medium rare, etc. And let's store the result in a new data frame. Okay, so the idea is that we will have each row being a type of a method of how steak is cooked, so medium rare, rare, and then we'll have a column that counts the number of people that fall into that category. So I gave a little hint here to use the by function, because what we need to do is group the data according to how they like it cooked, so how cooked. So this will make a group of data frames, and in each group, all the rows will correspond to people who like the steak cooked a certain way, the same way. All right, and then we would like to define a new column, say number of folks, because it's going to count the number of people. And that column is created by looking at, and it doesn't really matter which column you have here, you just want to look at the length. So for example, you can look at each steak. This is basically a way to count the number of rows in that data frame. So we'll map that column to length, right? It's just looking at the length. And what it's done is, this is the length of the first group, people who like their steak medium rare. This is the length of the second group, people who like their steak rare. So this is splitting the data frame according to this group, applying a function to each data frame in the group, this length function, and then it's combining the result and defining a new column, number of folks. So we see that most people like their steak medium rare. I don't fall into that category. All right, so there's an ordinality here in how well steak is cooked, but the data frame doesn't follow that, right? So rare is after medium rare, and then we have medium, medium well, and well. So we want to reorder these rows to get ready for plotting them. So let's do that by df steak prefs equals df steak prefs, and we'll reorder the rows. So let's see. First we should have row 2, and then 1, right? And then 3, 4, 5. And we want to keep the columns. Let's make sure that it's actually reordered here. Whoops. Let me rerun the loading of it so that everything can rerun. Okay, that's pretty weird. I'm not sure what's going on here. Let me delete this and start over. So I'm going to reorder the rows. Oh, okay, it's not allowing me because I've already defined it. So this is part of the reactive notebook thing. So if I use a dot here, that should allow me to do it by overwriting the memory. Yeah, and okay, so finally we have our reordered rows: rare, medium, medium well, and then well. So now it's ordered according to the notion of how cooking the steak more time. And there's no way the computer could have known that, right? Unless it had some machine learning algorithm. So we had to manually reorder those rows. Now we can finally draw a bar plot that shows how folks like their steaks cooked. All right. So to do that, we can use the bar. Well, first we'll make a figure. Whoops. First we'll bring up a figure panel. And then we will make a bar plot. And there's going to be 5 bars. So we'll give it the indices for those bars, 1 to 5. There's 5 bars. And then the length of the bars will be determined by the number of folks who eat that type of steak. So we'll just do that real quick to see how it looks. DF steak. Oh, I need to use this one, sorry. DF steak preferences. So we want to plot these numbers here. These are the lengths of the bars. And voila. And let's say we want to make the bars horizontal. I like horizontal bars. We'll put an H there to make them horizontal. Yeah. And so now on the x-axis we have how many folks, right? Number of folks, okay? On the y-axis we have how steak preference, how it's cooked. All right, and now we have a 1 through 5 here, but we'd like to put the names of how the steak is cooked. So you can do that by y-ticks. And you first specify where you want the y-ticks to be. We still want them to be at 1 to 5. However, we want the names to be labeled. These are the labels according to how cooked. And voila, we have a nice plot. So this is how many people. And you can see right away, okay, most people like medium rare, with medium the second most popular. Okay, so to make this plot a bit better, we can try to emphasize that there is an ordering here from well, medium, medium rare to rare by coloring it according to how for example, how hot the steak is after it comes out of the grill. I think that would be a cool way to spice up this data visualization. So in Matplotlib, they have color maps, and there's a whole host of different color maps that you might want to use under different circumstances. There's sequential color maps. There's diverging color maps, and this is good if one value is negative and one is positive. Cyclic color maps, this is good for drawing a periodic color map, for example, a unit circle. So what I thought was appropriate was the hot color map because it denotes heat. And so the way this works, this is basically a function, and it takes in a number between 0 and 1, so let's say 0.1, and it maps it to some color along that color bar. And this is an RGB, so first is the red, green, and then blue value, and then alpha, which gives transparency. So there's no transparency here. Okay, so that's sort of how this color map works. And so now we want to use the hot color map to color the bars. So I'll just say, see above. I'll just modify the above. So what we want to do is make colors for this, right? So we'll make a colors array. And this colors array is going to have 5 elements here, right? 1 for each type of steak. So we'll make that zeros. We'll just make it automatic. Instead of putting in 5, we'll say length of that. All right, and then we'll loop through the colors. Okay, we'll loop through the colors, and we'll assign color I to be, let's think about this. So we want the first one to be 0, and the last one to be 1. So we could start with I divided by, maybe it's easier if I just put 5 because there's going to be 5. Let's try I divided by 5, and then we'll look at the colors, okay? Oh, there's already a name called colors, so let's call it bar colors. How about that? All right, so now let's look at what bar colors is. All right, and you can see the first one is 0.2, and the last one is 1, which is what we want, but we want the first one to be 0, so we can explore the whole color range. To do that, we can put an I minus 1 here, so it starts at 0, and divide by 4 instead, okay? And there we go. That's what we want. And so now we can pass in colors equals color. Whoops, bar colors. And it should color the bars according to this color map. Yeah. So why isn't it working? Let's see. Oh, I know why. So I'm putting in these numbers, but I need to convert that to a color. So I need to pass this through the color map, right? So hot CMap, right? Because I want to map this number to a color. So let's look at what this is now. So bar colors. Okay. I initialize this as zeros, right? So instead, make this an array of colors. So we'll initialize this as colors first. So hot CMap. In fact, we can just do this in one line, really. Okay. So we want this to be element I. For I equals 1 to 5, right? Yeah, and this will automatically make it an array of colors. So I'm using a list comprehension instead. Okay, and we get another error, which is, let me look at bar colors. So let's see, what is wrong with this? Rectangle has no property colors, and that's because this is just color. Yeah, okay, cool. Oh, okay, yeah, and look. So now we have rare is black, and we have well is appearing white. Okay, so that's not good to have it white, right? Because now you can't see the bar. So one thing that we could do is put an edge around here. So we could say there's an edge color. But then if we make the edge color, it would look a bit weird because if we make the edge color black, for example, rare would appear not to have an edge color. But we can try that. So EC equals K. Yeah, and now you can see that well is, you can see the length now. So the problem is that, rare, well is like black, right? Because it's charged. So we want to reverse this. And so you can do that in the color map by putting an R here. So let's see, hot CMap. Where do we define that? Where is hot CMap? Oh, it's right here. So this is your hot color map. And now things are getting weird because I define this. I define this below the plot, but it still works miraculously. So you can put an R here, I believe, and that will reverse it for you. Let's see. R hot. Does that work? Oh, you have to put an underscore R. So hot underscore R, and that will make it reverse. There we go. Yep. Fantastic. And now, finally, well is black, and then medium rare is yellow. So it's sort of how hot the steak is as it comes out the grill. This is not cooked much at all. So yeah, that's how you make a bar plot and tune the properties of it. And really, to be fair, I should put this... all of this code down here because it's awkward to use this hot CMap before it is defined in the code. So I'm going to put this down here, right? And I'll get rid of this. Okay, so yeah, so I'm surprised that works actually. Okay. Yeah, there. Okay. So we started with our rudimentary bar plot, and then we have the colored one. Okay, so line plots with multiple series and a legend. Now let's think about line plots. So I put in two different files, xenon and krypton.csv. We'll look at them. So these ones have headers, which is good. So each of these corresponds to a gas, one xenon, one krypton. And the first column is the pressure of the gas. The second column is the amount of gas that is absorbed by a porous material. So we want to make these on the same plot so we can compare the xenon to the krypton absorption in the material. All right, so first we can read in these data frames. So you could do something like this, right? csv.read join path data xenon.csv. All right, so here's xenon, right? And then you can make another one for krypton, right? So instead of doing that, we can use a dictionary that maps the gas to a data frame. Because imagine you have 1,000 gases. You don't want to manually have 1,000 lines. So we'll say gases equals xenon and krypton. And we'll say for gas and gases. Okay. And now here we can put a gas. So gas star. So star is string concatenation. So that will take xenon and krypton and load in the appropriate file. And then we want to say gas to df, and this is going to be a dictionary, right? And it's going to map a string to a data frame. All right, and we're going to load in, we're going to make sure that this gas gets mapped to this data frame. Yeah, all right? So begin and end, and I'll show you what this does. All right, so now we have this dictionary. Okay. And it has two data frames. So if you call krypton, if you call xenon, it will return the xenon absorption. If you call krypton, it will return the krypton absorption. So it's a convenient way of storing two data frames in one data structure. And now we can make a line plot by looping over these gases similarly. Okay. So we want to plot each absorption isotherm, or each data set, on the plot, on the same plot. So we can loop through the gases again. We'll make our figure panel. And we'll plot on the x-axis gas to df gas. So that brings up the data frame for that gas. And we want to get the pressure, right? So that's this one. And you can see that you can't really make a symbol out of this with the colon. So you need to, unfortunately, say symbol, and you need to cast that string into a symbol because the space here in the parentheses will give you trouble. All right. So for example, this is how you can get pressure column. Whoops. Yeah, so that's how you get the pressure column. And so to help us with that, we can say pressure call equals symbol. And then we'll say uptake call equals symbol, just so I don't have to type that out all the time. Yeah, that's the uptake column. All right, so you want to plot the pressure column against gas to df. Let's bring up the data frame. We want all the rows against the uptake column, right? And then we'll also, okay, well, I'll just show you what this looks like first. So I like to, make sure everything's working right. All right, so there we go. There's the two curves. So we'll give the X label, pressure, put the units there, Y label, uptake, millimoles per gram. All right, so title, we'll say xenon and krypton adsorption. And I think this is Noria. That's where it comes from. That's the type of material it is. So there's our nice title. Okay, yeah. And if you want to have a grid there, you can say grid on to make a grid. So there's a nice grid. And if you want to have points, so this is really discrete data. It's not very smooth. You can see it looks a little jagged. So I like to include the points here too. So you can do that by saying marker equals O. Yeah, so you can put the markers there too. So you can see how resolute the data is. So the problem is that you don't know which one's xenon and which one's krypton, so we need a legend. Okay, we can do that by giving a label to each plot. So it's simply the gas. And then we'll call legend. All right, and we'll put our little legend right here. All right, and now for colorblind folks, or for anyone who is printing off in black and white, you might want to change the symbols here. That's always good practice. So you make a gas to symbol dictionary. All right, and xenon, we'll keep it to have the O, but maybe krypton, we'll make that have squares, S for square. And now when we do marker here, we'll say each gas gets a different marker, right? And now krypton has a square. So you could also change the color that way too, right? So if you really liked certain colors. So I'll copy this. So maybe I want green for xenon. And maybe I want red for krypton. So you can pass color equals gas to color, gas, and change the properties of that data series in there. Yeah, finally, I want to show you that you can also save a figure. So anytime I save a figure, I just put this in here. I think of this as a command that magically makes sure that your whole panel is in your saved figure. So I always put that there when I save a figure. Otherwise, you'll see like X labels being cut off oddly. So you can save fig myplot.pdf, and you say format equals PDF. You can also save as a PNG, but I like PDFs because they're vector format. Right, and now XDG. Open. So this is called myplot. And then we'll see a nice PDF of our plot that we could use for a publication. Yeah. So yeah, I introduced bar plots and line plots where you have different series and a legend. So I hope this was helpful for exploring what Matplotlib can do, and will give you a good jump start. Thanks.